This is R.D. Sharma solution, class 12, increasing and decreasing function. The exercise is 17.1 of chapter number 17. Before we go ahead with the questions and solving the questions, the first thing is we don't have to use a dy by dx or derivative to solve these questions. So the question arises, how are we going to do it? First is, why do we need dy by dx or the slope or the differentiation? Now assume this to be a mountain you are climbing up or you are coming down. So in mathematics also, the increasing and decreasing function is like this only. That is, if we make a tangent, and what is the tangent? Dy by dx. If you have function, you just differentiate it, and if this function is greater than 0, then we say that this function is strictly increasing. If it is greater than or equal to, that is only increasing. Coming to this point while we are going down, so this f dash x, that is differentiation of the function, is less than or equal to 0, then it is decreasing. If it is less than 0, it is strictly decreasing. So the differentiation becomes very important in order to tell that whether the function is increasing or decreasing. Please remember that all these will be in certain domain. So the domain is infinite, from negative infinity to infinite. So there is infinite, and you will say what is infinite? That is a number which we cannot count. You give me a number, I'll add a 1, and then that will be the next number. So this infinite can be shown using the number line, because number line will be used a lot here in these questions. So the next thing is, without a differentiation, it will be very difficult. But this exercise is without differentiation. Prove that the function log base ex is increasing on 0 to infinite. So in the center of infinite and negative infinite, 0. So 0 to infinite, the question is saying we are going on the right from 0 to infinite. So when we solve this kind of question, the first thing comes is 0 to infinity. That is, we always try to make a number line, and we say that there are two numbers, x1 is lower, x2 is higher, and we say this belongs to 0 to infinity. What does it mean? In order to define this x1 and x2, we are in the 0 to infinite domain. So 0 to infinite goes to say 1, 200, lakh, 10 lakh, 10 crore. It is infinite. But we are taking any two numbers in this 0 and infinite. It can be any number. So when we are talking about increasing and decreasing, if we want to show increasing, then we have to say that this x1 and x2, there are two numbers. x1 is the first number, x2 is the second number. That means x1 is lower than x2. In numbers, if I want to tell you, let us say x1 is 3 and x2 is 4. So 3 is less than 4. That you understood? Now when you take the log, what will happen? This log is base e, that is called the natural log. If I call this y1 as log x1 and if I call y2 as log x2, it just means that e raise y1 is equal to x1. Here e raise y2 is equal to x2. So if I am saying x1 is less than x2, which I started, we took two numbers. We said that one number is lower than other one. We took the log of both the numbers. So what does that log means? Here I have just equated it with y1 and y2. So if this x1 and x2 is 3 and 4 and e is a constant value which is 2.17, so this y1 and y2 should also follow the same angle or same relationship. That is, y1 has to be less than y2 because e is a constant. If you take the constant and raise it to certain power, then it has to follow that if x1 and x1 is less than x2, then y1 has to be less than y2. So y1 should be less than y2. You can take any number between 0 to infinite and you can just verify it and check it. So I'm just saying log x1 is less than log x2, and log x1 is what? See, fx is log x, so fx1 will be log x1. So log x1 is fx1 only, this is function only, and log x2 is fx2. That is the value of the function at x1 and x2 which we took random values between 0 and infinite. Because it is natural log, the x1 less than x2 implies that the function, that is fx1, is also less than fx2. If x1 is 3, x2 is 4, if 3 is less than 4, then the log of 3 and log of 4 has the same relation, that log of 3 is less than log of 4. Alright? You can also find out the value of log 3 and log 4, and you can verify it also. Because we are not writing number here, we don't have to write any number here. 3 and 4 is just for example. So for any x1 and x2 which is belonging to 0 and infinite, fx1 is less than fx2 if x1 is less than x2. So this 3 and 4, I just gave you an example that if 3 is less than 4, the value of the function at 3 and value of the function at 4 is also like this, that fx1 is or f3 is less than f4. So fx is increasing. So in 0 and infinite. Now this most of the people, they say that we have to write, you have to give us all the explanation in written. So that's why I always show the reference, because you need to solve it also. You have to write it somewhere also, because writing takes a lot of time. My intention is that you should know the logic first, how to solve it. Writing you can develop. Now this is also a very good question, and this always comes in the exams. See, this is the function, log function. This is how it is being drawn. This is a critical point, and this is x is 1, y is 0. So that is why this 1 and 0 plays a very important role. And this a is, I'm taking the a on the number line, not the x, okay? Now this a is between 0 and 1. This is the one case they are asking about, and they are also asking about when this a is greater than 1. So there are two cases, and this is not a natural log. Please remember, this is not the base e. That is why the a is very important here. I told you about log, you know about log, but it was natural log. But here we have the base a, and this has to be computed, or we have to show that it is increasing if a is greater than 1 and it is decreasing if a is between 0 and 1. So just assume, as we did in the previous question, any value between 0 and infinite, x1 and x2, and these two value, we always take x1 lower than x2, but there will be two cases, because the question is asking about two cases that show that it is increasing, show that it is decreasing. So if a is greater than 1, it is increasing. That is, we are talking about, say, a is 2, 3, 100, lakh, 10 lakh, that is the base of log. So we are assuming that x1 is less than x2. Again, we are going like this, that if this is the increasing x1 and x2, we are taking these 2 points, and x1 is lower than x2. This is what we are assuming. So if x1 is less than x2, if we take log of x1 and log of x2, just put log in front of x1 and x2, but the base is a. Since a is greater than 1, the value of x log, that is log of x1 and log of x2, will follow the same relationship. I told you that the base of log is normally e, which is 2.178. which is a positive value, which is greater than 1 also. Here also the same case, a is greater than 1. So I don't think there is no more discussion required, because natural log, if it follows the same thing, the base a, if it is not e, it is a, which is already a greater than 1, which is positive number. So fx1 will be less than fx2. So we are saying x1 is less than x2 implies that the function also, that is the fx1, which is log a x1, and fx2, which is log a x2, will follow the same relationship, which is the less relationship. That is why the function is increasing in 0 to infinite. Now coming to a very, very different situation here, which is the case 2. We are saying that x1, again, we are saying x1 is less than x2. Same thing. x1, x2, we took it between 0 and infinite. We are saying x1 is less than x2, but now a is between 0 and 1. Again, taking log on both the sides of this less than relationship between x and x2, but it is not less than. When you take a between 0 and 1, it will be greater. Just assume that I am taking half. A is between 0 and 1, just take a random value, which is half. We are calling this log x1, call it as y1, say. That means a raised y1 is equal to x1. This you already know. Let us call log x2, that is base a, as y2. That only means a raised y2 is equal to x2. So x1 is less than x2. What will be y? Whether y1 is less than y2 or y1 is greater than y2. I am saying I am taking a random number, say between a as 0.5, half. Okay. So this a is 0.5. Now this is 0.5. I am taking a random number just to show you that why it is greater. So 0.5 to the power y1 and 0.5 to the power y2 is equal to, say, x1 and x2. x1 is 3, x2 is 4, 3 is less than 4. Now y1 is greater than y2 or y2 is greater than y1. I'm saying that just take, this is half, okay, 0.5 is half. Now call it as, say, take square. Just take square and take cube also. Half square is what? 0.5, 0.5. Half square is 0.5. What is half cube? Is 0.125. What is bigger, 0.5 or 0.125? 0.125 is lower than 0.25. Okay. So if 3 is less than 4, for example, this is just an example. 3 is less than 4. That doesn't mean that 0.4 is less than 0.125. It is actually greater. So when x1 is less than x2, log base a x1 is greater than log base a x2. So x1 is less than x2. That means in this case, when a is between 0 and 1, this is fx1 and fx2. That means fx1 is not less but greater than fx2. It is not equivalent to the case 1. That is why the function is decreasing 0 to infinite if a is between 0 and 1. So I hope you got the idea. So let me show you the way you are going to solve it. And please remember, you don't have to use any differentiation here. Prove that the function fx is equal to ax plus b, where a and b are constants. These values will not change. Let me tell you first the constant, because people get confused with that also. 2 is a constant. 2.1 is a constant. X and y, whichever you see, are variables. Normally in mathematics, a, b, c are constant. That is why we represent a, b, c by constant. X, y, z are the variables. So 10.2 cannot change. You do whatever with them. 10.2 will retain its value. And here it is saying that a is greater than 0. Again, if a number line is there, you're talking about a always lies between 0 and infinite. So it will always have a positive value. So you have to show that the function ax plus b, where a and b are constant and a is greater than 0, is an increasing function on R. R is what? A real number. Any number which can be represented on a real number line, all are real number. It will have decimal values, it will have positive values, it will have negative values. So this a is greater than 0 is also very important in solving this question. So we'll follow the same rule. First of all, we'll take two values x1 and x2, or assume two values x1 and x2, and it is belonging to the real number domain, and we are saying x1 is less than x2. That is, for example, we are taking 1 as 3, 1 as 4, 3 is less than 4. So this is what we are saying. I'm just telling you the examples also so that you understand that what it actually means when we say x1 is less than x2. 3 is less than 4. x1 has to be some value, x2 has to be some value. So I'm just giving an example that x1 may be 3, x2 may be 4, and 3 is less than 4, like this. Now let us multiply both sides by a. Please remember, a is a constant number. Please remember, a is a greater than value number. So when a is greater than 0, let me give you one more example here to make you understand. If you multiply both sides by 2, 6 and 8, 6 is less than 8. So this relationship of less than will never change. When you multiply it by negative, it will be, the angle will change. So but a is greater than 0. So this will never happen in this case. So it will always be the less than relationship. So when you multiply both sides by the positive value, the less than relationship will not change. So if x1 is less than x2, multiplication of any positive value will not change the less than relationship. Now add a b here. Take any b constant which is given in the question and just add. Again, b is a constant. Now it can be positive, it can be negative, because it is a real number. I am saying 3 and 4 is there. If I subtract both sides by 1, it will be 2 and 3. Or if you add, say, 1, it will be 4 and 5. In both the cases, 2 is less than 3 and 4 is less than 5. So even if you add a b, the less than relationship will not change. So this ax1 plus b is what? Fx is ax plus b. So fx1 will be what? Ax1 plus b. Fx2 is what? Ax2 plus b. So this ax1 plus b is nothing but fx1 only. That is the function only. And this is fx2. That means that if x1 is less than x2, this implies, this tells, this proves, that indicates, that signifies that fx1 is less than fx2. If two numbers you take, if they have certain relationship, the function also have the same relationship. In this case, the less than, that is, function is increasing in the domain real number. Okay, now let me show you how you're going to do it. Please remember, you don't have to use any differentiation here, and these are the steps you're going to follow to make it understand.